What if the universe is hiding secrets so strange, so baffling, that even the brightest minds on Earth can't explain them? Picture this, a signal from deep space, so powerful and precise that it was heard only once and never again. Or a star that dims and brightens in ways that defy every law of physics we know. These aren't scenes from a sci-fi movie, they're real, and they're just the beginning. Welcome to a journey through 30 of the most mind-bending space discoveries that leave scientists scratching their heads. From mysterious radio bursts to galaxies that shouldn't exist, these phenomena challenge everything we think we know about the cosmos. They remind us that the universe is far stranger, far more mysterious than we could ever imagine. So, are you ready to explore the unexplained, to dive into the cosmic riddles that keep astronomers up at night? Stick around, because by the end of this video, you'll see the universe in a whole new light, and you might just question everything you thought you knew about space. Let's begin. Now, let's dive into one of the most famous mysteries in the history of space exploration, the WOW signal. Back in 1977, a radio telescope known as the Big Ear, located in Ohio, picked up something extraordinary. For 72 seconds, a powerful, narrowband radio signal burst through the cosmos, so intense that it stood out like a beacon in the vast silence of space. The astronomer who discovered it, Jerry Amon, was so stunned by the data that he circled it on the printout and wrote "WOW" in the margin, giving the signal its iconic name. What made this signal so remarkable? For starters, it was incredibly strong, about 30 times louder than the background noise of space. It also matched the expected characteristics of a signal that could originate from an intelligent extraterrestrial source. The frequency it used, around 1420 MHz, is a protected band in radio astronomy, meaning it's reserved for scientific use and free from interference by human-made signals. This added to the intrigue. Was it a message from another civilization? Over the decades, scientists have tried to explain the WOW signal. Some suggest it could have been a natural phenomenon, like a comet or a distant star emitting an unusual burst of energy. Others argue it might have been a reflection of a human-made satellite bouncing off space debris. But here's the kicker: despite countless attempts to detect it again, the signal has never been heard since. It's as if the universe whispered a secret and then fell silent. The WOW signal remains one of the most tantalizing mysteries in the search for extraterrestrial intelligence. It challenges us to ask, are we alone in the universe, or was this a fleeting glimpse of something or someone out there trying to make contact? Whatever the truth, the WOW signal continues to captivate scientists and dreamers alike, reminding us that the cosmos is full of surprises waiting to be uncovered. Now, let's turn our attention to another cosmic enigma that has left astronomers scratching their heads: Tabby's star, also known as KIC 8462852. Located roughly 1,400 light-years away in the constellation Cygnus, this star has become famous for its bizarre and unpredictable dimming patterns. Unlike most stars which dim in regular, predictable cycles, Tabby's star experiences sudden, dramatic drops in brightness, sometimes by as much as 22%. These dips are so unusual that they've sparked a whirlwind of theories, ranging from natural explanations to the tantalizing possibility of alien megastructures. The story of Tabby's star began in 2015, when citizen scientists analyzing data from NASA's Kepler Space Telescope flagged it as unusual. Named after astronomer Tabitha Boyajian, who led the initial study, the star quickly became a sensation. One of the most intriguing explanations for its behavior is the idea of a Dyson sphere, a hypothetical megastructure built by an advanced civilization to harness the energy of a star. While this idea captures the imagination, scientists have been careful to explore all possibilities, including more mundane explanations like swarms of comets, dust clouds, or even a massive planetary collision. Despite years of observation and analysis, Tabby's star continues to defy explanation. Researchers have ruled out some theories, such as instrumental errors or a young star surrounded by a protoplanetary disk, but the mystery remains unsolved. What makes this star so fascinating is not just its strange behavior, but what it represents. A reminder that even in an age of advanced technology, the universe still holds secrets that challenge our understanding. As we continue to study Tabby's star, it serves as a humbling reminder of how much we have yet to learn about the cosmos. Whether the answer lies in natural phenomena or something more extraordinary, this star keeps us asking questions and pushing the boundaries of our knowledge. And who knows, the next breakthrough might just come from you watching this video and wondering what else is out there in the vast expanse of space. Now, shifting our gaze from the mysteries of Tabby's star, we encounter one of the most profound questions in the search for extraterrestrial life, the Fermi Paradox. Named after physicist Enrico Fermi, who famously asked, "Where is everyone?" This paradox highlights the striking contradiction between the high probability of alien civilizations existing in the universe and the complete lack of evidence for their existence. With billions of stars in our galaxy alone, many of which host Earth-like planets, why haven't we detected any signs of intelligent life? The Fermi paradox begins with a simple observation. The universe is unimaginably vast and old, offering ample time and space for life to emerge and evolve. Statistically speaking, the odds seem overwhelmingly in favor of extraterrestrial civilizations existing somewhere out there. Yet, despite decades of searching through radio signals, telescopes, and other methods, we've found nothing. No signals, no artifacts, no definitive proof. This silence has led scientists to propose a range of explanations, each more thought-provoking than the last. One of the most compelling theories is the idea of the Great Filter. This concept suggests that there's some kind of barrier, a filter, that prevents civilizations from reaching a stage where they can communicate across the stars. The filter could lie in our past, meaning that the emergence of intelligent life is extraordinarily rare, and we're one of the lucky few to have made it this far. Alternatively, the filter might be ahead of us, implying that advanced civilizations inevitably destroy themselves before they can make contact, whether through war, environmental collapse, or some other catastrophic event. Another possibility is that intelligent life is simply too rare. Even if life itself is common, the leap to complex, intelligent beings capable of building civilizations might be an incredibly unlikely event. Or perhaps alien civilizations exist, but they're so advanced that their technology and methods of communication are beyond our current understanding, making them invisible to us. Some even speculate that advanced civilizations might deliberately avoid contact, either to protect us or to protect themselves. The Fermi paradox doesn't just challenge our understanding of the universe, it forces us to confront profound questions about our own existence and future. Are we alone in the cosmos, or is the universe teeming with life we simply can't detect yet? As we continue to explore the stars, this paradox reminds us that the search for answers is as much about understanding ourselves as it is about discovering what lies beyond. And with every new discovery, we inch closer to unraveling one of the greatest mysteries of all. Moving from the profound questions raised by the Fermi paradox, we now turn our attention to one of the most enigmatic components of the cosmos, dark matter. This invisible substance makes up roughly 27% of the universe, yet it remains one of the greatest mysteries in modern science. Unlike ordinary matter, which forms stars, planets, and everything we can see, dark matter doesn't emit, absorb, or reflect light, making it completely invisible to our telescopes. So, how do we even know it exists? The story of dark matter begins with observations that simply didn't add up. In the 1930s, astronomer Fritz Zwicky noticed that galaxies within clusters were moving far faster than they should based on the visible matter alone. According to the laws of gravity, these galaxies should have flown apart, but something unseen was holding them together. Decades later, Vera Rubin's groundbreaking work on galaxy rotation curves confirmed this anomaly. Stars at the edges of galaxies were orbiting just as fast as those near the center, defying expectations. The only explanation: a massive amount of invisible matter was providing the extra gravitational pull needed to keep these stars in place. But what exactly is dark matter? Scientists believe it's a type of particle that doesn't interact with light or ordinary matter, except through gravity. This makes it incredibly difficult to detect directly. Despite decades of searching with sophisticated detectors buried deep underground to shield them from cosmic interference, we've yet to capture a single dark matter particle. Yet, the evidence for its existence is overwhelming. From the way galaxies rotate to the bending of light around massive objects, a phenomenon known as gravitational lensing, dark matter's gravitational effects are everywhere. One of the most compelling pieces of evidence comes from the cosmic microwave background, the faint afterglow of the Big Bang. Tiny fluctuations in this ancient light reveal how matter was distributed in the early universe, and the patterns we see only make sense if dark matter was present, shaping the cosmos from the very beginning. Without it, galaxies, stars, and planets might never have formed. So why is dark matter so elusive? The answer lies in its very nature. If it doesn't interact with light or ordinary matter, detecting it requires entirely new methods and technologies. Scientists are exploring a range of possibilities, from searching for faint signals in particle colliders to studying the subtle effects of dark matter on the universe's structure. Some theories even suggest that dark matter might be made up of particles we haven't yet imagined, requiring a complete rethinking of physics as we know it. Dark matter isn't just a scientific curiosity, it's a fundamental piece of the cosmic puzzle. Without it, our understanding of the universe would be incomplete, and many of the phenomena we observe would remain unexplained. As we continue to probe its mysteries, dark matter challenges us to think beyond the limits of our current knowledge and explore the hidden depths of the cosmos. And with every new discovery, we come one step closer to unraveling the secrets of this invisible force that shapes the universe. Now, shifting our gaze from the invisible grip of dark matter, we encounter another cosmic enigma that defies explanation: dark energy. This mysterious force is not only shaping the universe but accelerating its expansion, a discovery that has left scientists both awestruck and puzzled. Imagine the universe as a balloon constantly inflating. Instead of slowing down over time as one might expect, the expansion is speeding up. But what could be driving this cosmic acceleration? The story of dark energy begins in the late 1990s, when two independent teams of astronomers were studying distant supernova to measure how fast the universe was expanding. To their astonishment, they found that these exploding stars were farther away than they should have been, indicating that the universe wasn't just expanding, it was doing so at an ever-increasing rate. This groundbreaking discovery earned the teams the Nobel Prize in Physics in 2011 and fundamentally changed our understanding of the cosmos. So, what exactly is dark energy? Unlike dark matter, which pulls things together through gravity, dark energy appears to be a repulsive force pushing galaxies apart. Scientists estimate that it makes up about 68% of the universe, dwarfing even the influence of dark matter. Yet, despite its dominance, dark energy remains one of the most elusive concepts in physics. One leading theory suggests it could be a property of space itself, often referred to as the cosmological constant, a term Albert Einstein once introduced and later dismissed as his greatest blunder. Ironically, it might now hold the key to understanding the universe's expansion. The implications of dark energy are profound. If the universe continues to expand at an accelerating rate, distant galaxies will eventually move so far away that they'll vanish from our view, leaving future civilizations with a much emptier cosmos. This raises questions about the ultimate fate of the universe. Will it end in a big freeze, where everything drifts apart into cold, dark isolation? Or could dark energy evolve in ways we can't yet predict? Despite its significance, dark energy remains one of the greatest unsolved mysteries in physics. Detecting it directly is nearly impossible because it doesn't interact with light or matter in any observable way. Instead, scientists rely on indirect methods, such as mapping the large-scale structure of the universe or studying the cosmic microwave background to infer its presence and effects. Some even speculate that dark energy might be connected to entirely new physics beyond our current understanding of the universe. Dark energy challenges us to rethink the very fabric of reality. It's a reminder that the cosmos is far stranger and more complex than we ever imagined. As we continue to explore its mysteries, we're not just uncovering the secrets of the universe, we're also confronting the limits of human knowledge. And with each new discovery, we inch closer to understanding the forces that shape our existence, even as they remain shrouded in mystery. Now, let's turn our attention to one of the most fleeting and mysterious phenomena in the cosmos: fast radio bursts, or FRB. These are incredibly powerful bursts of radio waves that last just milliseconds, yet they release as much energy as the sun does in an entire day. First discovered in 2007, these bursts originate from deep space, often billions of light years away, and their sudden, unpredictable nature has left scientists scrambling for answers. So, what exactly are fast radio bursts? Imagine a flash of radio light so intense that it can be detected across the universe, but so brief that it's gone before you can blink. That's an FRB. Since their discovery, hundreds of these bursts have been detected, but only a handful have been traced back to their source galaxies. This makes them not only fascinating but also incredibly challenging to study. One of the leading theories suggests that FRBs could be linked to neutron stars, particularly a type known as magnetars. These are highly magnetic, rapidly spinning remnants of supernova explosions. When a magnetar's magnetic field undergoes a sudden shift or fracture, it could release a colossal burst of energy, potentially explaining the origin of FRBs. In fact, in 2020, astronomers detected an FRB coming from a magnetar within our own galaxy, providing the strongest evidence yet for this theory. But not all FRBs fit neatly into this explanation. Some bursts repeat, sending out multiple signals over time, while others are one-off events. This has led to speculation that there might be multiple causes for FRBs. Could some of them be the result of cataclysmic events, like the collision of two neutron stars or the collapse of a black hole? Or, more intriguingly, could they be artificial in origin signals from advanced extraterrestrial civilizations? While this idea captures the imagination, scientists caution that extraordinary claims require extraordinary evidence, and so far, no definitive proof of alien involvement has been found. What makes FRBs even more puzzling is their ability to travel such vast distances without being completely scattered or absorbed. This suggests that the environments they pass through are incredibly sparse, possibly pointing to regions of the universe with very little matter. Some researchers even propose that FRBs could be used as cosmic probes, helping us map the distribution of matter in the universe by studying how their signals are distorted as they travel through space. Despite the progress made in understanding FRBs, they remain one of the most enigmatic phenomena in astronomy. Why do some repeat while others don't? What exactly powers these bursts, and could they truly be a sign of intelligent life elsewhere in the universe? Each new detection brings us closer to answers, but for now, fast radio bursts continue to defy explanation, reminding us just how much we still have to learn about the cosmos. As we move forward, the search for FRBs is only intensifying, with new telescopes and technologies being developed to capture and study these elusive signals. Who knows what secrets they might reveal about the universe or even about ourselves? Now, let's shift our gaze to another cosmic mystery that has left astronomers scratching their heads: the Great Attractor. This enigmatic gravitational anomaly is pulling entire galaxies, including our own Milky Way, toward it at astonishing speeds. Located roughly 250 million light-years away in the direction of the constellations Centaurus and Hydra, the Great Attractor is a region of space with such immense gravitational pull that it's reshaping the motion of galaxies on a colossal scale. But here's the catch: studying the Great Attractor is no easy task. It lies in a part of the sky known as the Zone of Avoidance, an area obscured by the dense dust and stars of the Milky Way's galactic plane. This makes it incredibly difficult for astronomers to observe directly, as the dust blocks much of the visible light and other wavelengths from reaching our telescopes. It's like trying to peer through a thick fog to see what's on the other side. Despite these challenges, scientists have managed to piece together some clues about this mysterious region. Using instruments that can detect X-rays and infrared light, which can penetrate the dust, they've discovered that the Great Attractor isn't just a single massive object, but rather a concentration of mass, likely a supercluster of galaxies. This supercluster, known as the Norma cluster, is surrounded by other galaxy clusters, creating a gravitational focal point that's tugging on everything in its vicinity. The implications of the Great Attractor are profound. It's not just pulling our galaxy, it's influencing the motion of thousands of others, reshaping the large-scale structure of the universe. Some researchers even suggest that the Great Attractor itself is being pulled toward an even larger structure, known as the Shapley supercluster, which lies beyond it. This cosmic tug-of-war hints at a universe far more interconnected and dynamic than we once imagined, yet many questions remain. What exactly is the source of the Great Attractor's immense gravitational pull? Is it simply the combined mass of the galaxies in the Norma cluster, or is there something even more massive hidden within? And how does this gravitational anomaly fit into our understanding of dark matter and dark energy, which are already reshaping our view of the cosmos? As we continue to develop new technologies and observational techniques, the Great Attractor remains a tantalizing mystery, reminding us that even the most familiar regions of the universe can hold secrets waiting to be uncovered. What we learn from this gravitational enigma could reshape our understanding of the cosmos and our place within it. Now, let's turn our attention to a visitor from beyond our solar system, Oumuamua. This mysterious interstellar object made headlines in 2017 when it zipped through our cosmic neighborhood, leaving scientists both fascinated and puzzled. Unlike anything we've seen before, Oumuamua's unusual characteristics sparked intense debate and speculation about its origins and nature. First, let's talk about its shape. Most asteroids and comets in our solar system are roughly spherical or irregularly shaped, but Oumuamua was different. Observations suggested it was elongated, almost cigar-shaped, with a length estimated to be about 10 times its width. This bizarre form was unlike any natural object we've encountered, raising questions about how such a structure could form in the first place. Then there's the matter of its acceleration. As Oumuamua traveled through our solar system, it didn't just follow the expected path dictated by gravity. Instead, it sped up slightly, as if something was pushing it. This unexpected behavior couldn't be explained by the gravitational pull of the sun or planets alone. While comets often accelerate due to outgassing, the release of gas and dust as they heat up Oumuamua showed no visible signs of a coma or tail, the typical hallmarks of a comet. So, what was causing this acceleration? Scientists were left scratching their heads. The mystery deepened when some researchers proposed that Oumuamua might not be a natural object at all. Could it be an alien probe or spacecraft? The idea gained traction because of its peculiar shape and unexplained acceleration. Some speculated that it might be a solar sail, a thin, reflective structure propelled by sunlight sent by an advanced extraterrestrial civilization. While this theory captured the public's imagination, most scientists remain skeptical, arguing that natural explanations are more likely, even if we haven't figured them out yet. So, what do we know for sure? Oumuamua is the first confirmed interstellar object to pass through our solar system, and its brief visit left us with more questions than answers. Was it a fragment of a distant planet, a shard from a cosmic collision, or something else entirely? The debate continues, and while we may never know the full story, Oumuamua serves as a reminder that the universe is full of surprises, waiting to challenge our understanding of the cosmos. As we move forward, the search for more interstellar visitors like Oumuamua is already underway, with new telescopes and instruments poised to detect them. Each discovery brings us closer to unraveling the mysteries of the universe, and who knows, the next interstellar object might just hold the key to unlocking secrets we've yet to imagine. Now, let's journey to one of the most baffling regions in the cosmos, the Borealis void. Imagine a space so vast and empty that it defies everything we know about the universe's structure. This enormous region, located in the constellation of Borealis, spans an astonishing 330 million light-years across, yet it contains almost no galaxies. To put that into perspective, if the Milky Way were placed in the Borealis void, our nearest galactic neighbor would be millions of light-years away. It's like a cosmic desert on a scale that's hard to comprehend. The Borealis void, sometimes called the Great Void, was discovered in the 1980s during surveys of galaxy distributions. Astronomers expected to find a relatively even spread of galaxies across the universe, but the Borealis void stood out as a glaring exception. Instead of the usual clusters and filaments of galaxies, this region is eerily sparse, with only a handful of galaxies scattered across its immense expanse. This discovery immediately raised questions. How could such a vast area of space be so empty? And what does its existence mean for our understanding of the universe? One theory suggests that the Borealis void formed as a result of smaller voids merging over billions of years. In the early universe, matter wasn't distributed evenly. Tiny fluctuations in density led to the formation of cosmic structures, with dense regions becoming galaxy clusters and less dense regions evolving into voids. Over time, these voids could have grown and merged, creating the enormous empty space we see today. However, this explanation still doesn't fully account for the sheer size of the Borealis void. It's so large that it challenges our current models of cosmic evolution, which struggle to explain how such a massive void could form naturally. Another intriguing possibility is that the Borealis void might be evidence of something even more mysterious, a collision with another universe. Some scientists speculate that our universe could be part of a multiverse, and the Borealis void might be the imprint of an interaction with a neighboring universe. While this idea is highly speculative, it highlights just how much the Borealis void pushes the boundaries of our knowledge. Its existence forces us to reconsider our assumptions about the universe's structure and the processes that shape it. The Borealis void isn't just a curiosity, it's a cosmic puzzle that challenges our understanding of the universe on a fundamental level. Its vast emptiness raises questions about the distribution of matter, the nature of cosmic voids, and even the possibility of other universes. As we continue to explore the cosmos, discoveries like the Borealis void remind us that the universe is far stranger and more mysterious than we ever imagined. And who knows, the answers to these questions might just reshape our understanding of reality itself. Now, shifting our gaze from the vast emptiness of the Borealis void, let's turn our attention to a mystery much closer to home, the Pioneer anomaly. In the late 1970s and early 1980s, as the Pioneer 10 and Pioneer 11 spacecraft ventured beyond the outer planets, scientists noticed something strange. These spacecraft, which were designed to explore the far reaches of our solar system, began to slow down in a way that couldn't be explained by gravity alone. This unexpected deceleration became known as the Pioneer anomaly, and it puzzled researchers for decades. The Pioneer spacecraft were launched in the early 1970s, with Pioneer 10 becoming the first human-made object to travel through the asteroid belt and fly by Jupiter. Pioneer 11 followed, visiting both Jupiter and Saturn. After completing their missions, both spacecraft continued their journey into deep space, sending back valuable data about the outer solar system. But as they moved farther from the Sun, scientists noticed that their trajectories were slightly off. The spacecraft were slowing down more than expected, as if an unseen force was tugging on them. This tiny but consistent deviation was just enough to raise eyebrows and spark a scientific mystery. At first, researchers considered the possibility of errors in their calculations or measurements. Could it be a glitch in the data, or perhaps an overlooked factor in the spacecraft's design? But after thorough analysis, the anomaly persisted. The spacecraft were indeed slowing down, and no one could explain why. This led to a flurry of theories, ranging from the mundane to the extraordinary. One of the leading explanations focused on thermal radiation. The Pioneer spacecraft were powered by radioisotope thermoelectric generators, which produced heat as a byproduct. Scientists speculated that this heat, radiating unevenly from the spacecraft, could have created a tiny but measurable force pushing against their motion. This theory gained traction because it relied on known physics and didn't require any new or exotic explanations. However, even after detailed modeling, the thermal radiation hypothesis couldn't fully account for the observed deceleration. There was still a gap that needed to be explained. This gap opened the door to more speculative ideas. Could the Pioneer anomaly be evidence of new physics? Some scientists suggested that it might point to flaws in our understanding of gravity. Perhaps Einstein's theory of general relativity, which has been the cornerstone of modern physics, needed to be revised. Others proposed that dark matter or dark energy, the mysterious forces shaping the universe, might be influencing the spacecraft in ways we don't yet understand. While these ideas were intriguing, they lacked concrete evidence, leaving the Pioneer anomaly as an unsolved puzzle. Over time, as the spacecraft's power dwindled and their signals grew faint, the mystery of the Pioneer anomaly faded from the spotlight. But its legacy remains. It serves as a reminder that even in our own cosmic backyard, there are phenomena that defy explanation. The Pioneer anomaly challenges us to question our assumptions and keep exploring, because sometimes the smallest deviations can lead to the biggest discoveries. And who knows, the answers to this mystery might still be out there, waiting to be uncovered. As we continue our journey through the cosmos, the Pioneer anomaly reminds us that the universe is full of surprises, even in the places we think we understand best. Up next, we'll explore another enigma that has captivated astronomers and conspiracy theorists alike: the Black Knight satellite. Stay tuned. Now, let's turn our attention to a mystery that has fueled both scientific curiosity and wild speculation: the Black Knight satellite. This enigmatic object, said to be an alien satellite orbiting Earth, has captured the imagination of conspiracy theorists and space enthusiasts for decades. But what is the Black Knight, and is there any truth to the claims surrounding it? Let's separate fact from fiction and uncover the real story behind this cosmic legend. The tale of the Black Knight satellite dates back to the late 1950s, when reports began circulating about an unidentified object in orbit around Earth. Some claimed it was an ancient alien artifact left behind by an advanced extraterrestrial civilization to monitor humanity. Others suggested it was a relic from a lost human civilization or even a secret government project. The stories grew more elaborate over time, with some even claiming that the satellite had been transmitting mysterious signals for thousands of years. But where did these stories come from? The origins of the Black Knight myth can be traced back to a few key events. One of the earliest was the detection of unusual radio signals by Nikola Tesla in the late 19th century. Tesla believed he had intercepted signals from another world. though modern scientists attribute these to natural phenomena like cosmic noise or interference. Decades later, in the 1950s, the United States and the Soviet Union began detecting unidentified objects in orbit during the early days of the space race. These detections were likely debris or experimental satellites, but they fueled speculation about extraterrestrial technology. One of the most famous pieces of evidence cited by Black Knight enthusiasts is a photograph taken during the Gemini 12 mission in 1966. The image appears to show a dark, irregularly shaped object floating in space, which some claimed was the Black Knight. However, NASA later identified the object as a thermal blanket that had been lost during a spacewalk. Despite this explanation, the photograph continues to be used as proof of the satellite's existence. So, what's really out there? While the Black Knight satellite itself is almost certainly a myth, there are real objects in orbit that may have inspired the legend. Space debris, defunct satellites, and even natural phenomena like meteoroids can sometimes appear mysterious when viewed from Earth. Additionally, the rapid pace of space exploration during the mid-20th century led to a flood of new discoveries, some of which were misinterpreted or sensationalized. The Black Knight satellite serves as a fascinating example of how mystery and imagination can intertwine with science. While there's no evidence to support the idea of an alien satellite orbiting Earth, the story continues to captivate those who dream of contact with other worlds. It also reminds us of the importance of critical thinking and the need to question extraordinary claims, especially in an age where misinformation can spread quickly. As we move forward in our exploration of space mysteries, the Black Knight satellite stands as a testament to humanity's enduring fascination with the unknown. Up next, we'll delve into another cosmic puzzle, the cosmic microwave background cold spot. What could this strange anomaly in the universe's oldest light tell us about the nature of reality? Stay tuned to find out. Now, let's journey deeper into the cosmos to uncover another baffling mystery, the cosmic microwave background cold spot. This peculiar anomaly, found in the oldest light in the universe, has left scientists scratching their heads for years. What makes this cold spot so unusual, and what could it possibly reveal about the nature of our universe? Let's dive in. The cosmic microwave background, or CMB, is often referred to as the afterglow of the Big Bang. It's the faint radiation that fills the universe, a snapshot of the cosmos when it was just 380,000 years old. Normally, this radiation is remarkably uniform, with tiny fluctuations that map the early seeds of galaxies and cosmic structures. But there's one region that stands out, a cold spot significantly cooler than its surroundings, spanning an area of the sky about 5 times the size of the full moon. At first glance, this cold spot might not seem like a big deal. After all, the CMB is full of small temperature variations, but this particular region is so unusually cold that it defies standard explanations. According to the laws of physics as we understand them, such a large and extreme cold spot should be incredibly rare, so rare, in fact, that its existence challenges our understanding of the universe. So, what could be causing this anomaly? One of the most intriguing theories suggests that the cold spot might be evidence of a collision with a parallel universe. Yes, you heard that right, a parallel universe. The idea is that our universe might have bumped into another bubble of spacetime during its early expansion, leaving behind a kind of cosmic bruise in the form of this cold spot. While this theory is speculative, it's a tantalizing possibility that could open the door to entirely new realms of physics. Another explanation points to a vast cosmic void, a region of space with far fewer galaxies and matter than average. If such a void exists in the direction of the cold spot, it could cause light passing through it to lose energy, creating the appearance of a colder region in the CMB. However, observations so far haven't found a void large enough to fully account for the cold spot's extreme temperature drop, leaving this theory incomplete. Some scientists have even proposed that the cold spot could be a statistical fluke, a rare but natural variation in the CMB. While this is possible, the odds of such a large and pronounced anomaly occurring randomly are astronomically low, making this explanation less satisfying for those seeking a deeper understanding of the universe. Despite decades of study, the cosmic microwave background cold spot remains one of the most puzzling mysteries in modern cosmology. Its existence challenges our models of the universe and pushes us to consider possibilities that were once the realm of science fiction. Whether it's evidence of a parallel universe, a cosmic void, or something entirely unexpected, this cold spot reminds us that the universe is still full of surprises. As we continue our exploration of space's greatest mysteries, the cold spot serves as a humbling reminder of how much we have yet to learn. Up next, we'll turn our attention to another cosmic conundrum, the missing baryon problem. Where is all the ordinary matter in the universe hiding, and why can't we seem to find it? Stay tuned to uncover the secrets of this elusive cosmic puzzle. Now, let's shift our focus to another cosmic mystery that has left scientists puzzled: the missing baryon problem. When we look at the universe, we expect to find a certain amount of ordinary matter, the stuff that makes up stars, planets, and even us. But here's the catch: a significant portion of this matter seems to be missing. Where did it go, and why can't we detect it? Let's unravel this enigma. Ordinary matter, also known as baryonic matter, includes protons, neutrons, and electrons, the building blocks of everything we see around us. Based on our understanding of the Big Bang and the formation of the universe, scientists have calculated how much of this matter should exist. However, when they tally up all the visible matter in galaxies, stars, and gas clouds, they find that a large fraction is unaccounted for. This discrepancy is what we call the missing baryon problem. So, where could this missing matter be hiding? One leading theory suggests that it exists in the form of hot, diffuse gas spread throughout the vast regions of space between galaxies. This gas is incredibly thin and faint, making it nearly invisible to traditional telescopes. Detecting it requires specialized instruments that can observe the universe in X-rays or ultraviolet light, which can reveal the faint glow of this elusive material. Another possibility is that the missing baryons are tied up in cosmic filaments, enormous, thread-like structures of gas that form a web connecting galaxies across the universe. These filaments are part of the cosmic web, the large-scale structure of the universe, and they contain vast amounts of matter. However, because they are so diffuse and spread out, they are incredibly difficult to detect directly. The search for these missing baryons has led scientists to use innovative techniques, such as studying the absorption of light from distant quasars as it passes through intergalactic gas. By analyzing how this light is absorbed, researchers can infer the presence and properties of the gas, even if it's too faint to see directly. These observations have provided some clues, but the full picture remains incomplete. One of the biggest challenges in solving the missing baryon problem is the sheer scale of the universe. The missing matter is spread over such vast distances that detecting it requires incredibly sensitive instruments and precise measurements. Even with advanced technology, we've only been able to account for a fraction of the missing baryons, leaving the rest still hidden in the cosmic shadows. The implications of solving this mystery are profound. Understanding where and how this matter is distributed could shed light on the evolution of the universe, the formation of galaxies, and even the nature of dark matter and dark energy. It's a reminder that, despite our technological advancements, the cosmos still holds many secrets waiting to be uncovered. As we continue our journey through the universe's greatest mysteries, the missing baryon problem stands as a testament to the complexity and wonder of the cosmos. Next, we'll explore another intriguing anomaly, the axis of evil. What could this mysterious alignment in the cosmic microwave background tell us about the universe? Stay tuned to find out. Now, let's turn our attention to another cosmic puzzle that challenges our understanding of the universe, the axis of evil. This mysterious alignment in the cosmic microwave background radiation has left scientists scratching their heads as it defies the expectations set by the standard model of cosmology. What could this strange pattern mean, and why does it matter? Let's dive in. The cosmic microwave background, or CMB, is the afterglow of the Big Bang, a faint radiation that fills the entire universe. It's like a snapshot of the universe when it was just 380,000 years old, and it provides crucial clues about the early cosmos. According to the standard model, this radiation should be evenly distributed, with tiny fluctuations that are random and isotropic, meaning they should look the same in all directions. But here's where things get weird. When scientists analyzed the CMB data, they noticed something unexpected. Certain patterns in the radiation appeared to align along a specific axis, almost as if the universe had a preferred direction. This alignment, dubbed the axis of evil, contradicts the principle of isotropy, which is a cornerstone of modern cosmology. If the universe is truly uniform and without a preferred direction, why does this alignment exist? One possibility is that the axis of evil is a statistical fluke, a random anomaly that just happens to appear in the data. However, the odds of such a pattern occurring by chance are incredibly low, leading many to wonder if there's something deeper at play. Could this alignment hint at new physics beyond our current understanding? Some theories suggest that it might be evidence of a pre-Big Bang structure or even a sign of a multiverse, where our universe is just one of many. Another explanation involves the influence of our own galaxy. The Milky Way's magnetic field and dust could potentially distort the CMB data, creating the illusion of an alignment. However, even after accounting for these factors, the axis of evil persists, leaving scientists with more questions than answers. The implications of this discovery are profound. If the axis of evil is real and not just an artifact of measurement, it could force us to rethink some of the most fundamental assumptions about the universe. It challenges the idea that the cosmos is isotropic and homogeneous, raising questions about the very nature of space and time. As we continue to probe the mysteries of the universe, the axis of evil serves as a reminder that there's still so much we don't understand. It's a tantalizing clue that could lead to groundbreaking discoveries, reshaping our understanding of the cosmos. Next, we'll explore another cosmic oddity, the Red Rectangle Nebula. What makes this nebula so unique, and what secrets does it hold? Stay with us to find out. Shifting our gaze to another cosmic marvel, let's explore the Red Rectangle Nebula, a structure so peculiar that it stands out even among the countless wonders of the universe. Located about 2,300 light-years away in the constellation Monoceros, this nebula earned its name from its striking rectangular shape and vivid red hue, a sight that defies the typical, more organic forms of most nebulae. But what makes this nebula so unique, and why does it challenge our understanding of stellar evolution? At the heart of the Red Rectangle Nebula lies a binary star system, where two stars orbit each other in a delicate cosmic dance. One of these stars is in the final stages of its life, shedding its outer layers into space. Normally, this process would create a spherical or irregularly shaped nebula, but the red rectangle's distinct geometric form suggests something far more unusual is at play. Scientists believe that the interaction between the two stars and the dense disk of dust and gas surrounding them is responsible for shaping the nebula into its rectangular appearance. As the dying star ejects material, the disk funnels it into two cone-shaped outflows which, when viewed from Earth, create the illusion of a rectangle. But the mystery doesn't end there. The Red Rectangle Nebula also emits a strange infrared glow, hinting at the presence of complex organic molecules known as polycyclic aromatic hydrocarbons, or PAH. These molecules are often found in regions where stars are born, but their presence in a dying star system is puzzling. Could this nebula be a cosmic laboratory where the building blocks of life are being forged in unexpected ways? Or is there another process at work that we have yet to uncover? What truly baffles astronomers is the nebula's symmetry. Most cosmic structures, from galaxies to star clusters, exhibit some degree of asymmetry, shaped by chaotic forces and random interactions. Yet the red rectangle nebula's near-perfect geometric form suggests a level of order that defies conventional explanations. Some theories propose that magnetic fields or the precise alignment of the binary stars could be responsible, but these ideas remain speculative. The nebula's structure continues to challenge our understanding of how such intricate shapes can form in the vast, often chaotic expanse of space. The red rectangle nebula serves as a reminder that the universe is full of surprises, constantly pushing the boundaries of what we think we know. Its bizarre shape and unusual properties invite us to question our assumptions and explore new possibilities. As we continue to study this enigmatic structure, we may uncover clues not only about the life cycles of stars, but also about the fundamental processes that shape the cosmos. Now, let's turn our attention to another cosmic phenomenon that defies explanation: the cannibal galaxy. What happens when a galaxy consumes its neighbors, and what can this tell us about the evolution of the universe? Stay with us as we unravel this fascinating mystery. Now, let's journey into the depths of the cosmos to uncover the secrets of the cannibal galaxy, also known as NGC 5128. This peculiar galaxy, located approximately 12 million light-years away in the constellation Centaurus, has earned its dramatic nickname for a reason. It appears to be devouring its smaller galactic neighbors. But what does it mean for a galaxy to eat another, and how does this process shape the universe as we know it? At the heart of NGC 5128 lies a supermassive black hole, surrounded by a chaotic swirl of dust lanes and young, bright star clusters. These features are telltale signs of a galaxy that has undergone a violent and transformative past. Astronomers believe that NGC 5128 was once a large elliptical galaxy, but its current structure suggests it has collided with and absorbed smaller spiral galaxies over billions of years. The remnants of these cosmic feasts are still visible today, as streams of stars and gas stretch across the galaxy's outer regions like crumbs left behind after a meal. One of the most compelling pieces of evidence for this galactic cannibalism is the presence of a massive dust lane that cuts across the galaxy's center. This dark, jagged band is thought to be the remains of a smaller spiral galaxy that was torn apart and consumed by NGC 5128. As the two galaxies merged, their stars and gas were pulled into new orbits, creating the chaotic and dynamic structure we observe today. The collision also triggered bursts of star formation, lighting up the galaxy with clusters of young, blue stars. But the implications of this phenomenon go far beyond the fate of a single galaxy. Galactic cannibalism plays a crucial role in the evolution of the universe itself. As larger galaxies consume smaller ones, they grow in size and mass, eventually becoming the dominant structures we see in the cosmos today. This process also redistributes gas and dust, fueling the birth of new stars and shaping the intricate web of cosmic structures that span the universe. In a sense, NGC 5128 is a living example of how galaxies evolve and adapt over time, driven by the relentless pull of gravity. Yet, the story of the cannibal galaxy raises intriguing questions. What happens to the smaller galaxies that are consumed? Do their stars and planets survive the merger, or are they destroyed in the process? And how does this process affect the supermassive black holes at the centers of these galaxies? While we have some answers, much about galactic cannibalism remains a mystery, inviting further exploration and discovery. NGC 5128 serves as a powerful reminder that the universe is a dynamic and ever-changing place, where even the largest structures are shaped by the forces of destruction and creation. As we continue to study this cosmic predator, we gain deeper insights into the processes that drive galactic evolution and the intricate dance of matter and energy that defines our universe. Next, we'll turn our attention to another extraordinary discovery, the diamond planet. What could a world made of diamond tell us about the diversity of planetary systems? Stay with us as we explore this glittering cosmic gem. Now, let's shift our gaze to a truly dazzling cosmic wonder, the diamond planet, officially known as quasar J1719-1438b. Imagine a world so extraordinary that its very composition defies our imagination. This planet, located about 4,000 light-years from Earth, is believed to be composed largely of diamond, making it one of the most exotic and intriguing objects in the universe. The story of the diamond planet begins with its parent star, a pulsar, a rapidly spinning neutron star that emits beams of radiation. Quasar J1719-1438b orbits this pulsar so closely that a year on this planet lasts just over 2 hours. But how did such a planet form, and how did it come to be made of diamond? The answer lies in a dramatic cosmic transformation. Astronomers believe that this planet was once a massive star, similar to our Sun, but its fate took a dramatic turn when it was pulled into the gravitational grip of the pulsar. Over time, the intense pressure and heat stripped away its outer layers, leaving behind a dense core of carbon. Under extreme conditions, this carbon crystallized into diamond, creating a planet unlike anything we've ever seen. The existence of the diamond planet challenges our understanding of planetary systems in profound ways. For one, it raises questions about the diversity of planets that can form in the universe. While we're familiar with rocky planets like Earth and gas giants like Jupiter, a diamond-rich world pushes the boundaries of what we thought was possible. It also highlights the incredible influence of extreme environments, such as those near pulsars, in shaping the properties of planets. The diamond planet is a testament to the fact that the universe is far more varied and unpredictable than we once imagined. But the mysteries don't end there. Scientists are still trying to understand how such a planet could survive the violent conditions near a pulsar. The intense radiation and gravitational forces should, in theory, tear apart any nearby objects. Yet, quasar J1719-1438b persists, defying expectations and offering a glimpse into the resilience of cosmic bodies. Its existence also opens up new possibilities for the study of planetary formation and evolution, particularly in extreme environments. The diamond planet is more than just a glittering curiosity. It's a window into the incredible diversity of the cosmos. It reminds us that the universe is full of surprises, waiting to challenge our assumptions and expand our understanding. As we continue to explore the mysteries of space, discoveries like this one inspire us to keep looking deeper, knowing that the next great revelation could be just around the corner. Next, we'll uncover the secrets of the mysterious radio circles, strange emissions that have left astronomers scratching their heads. What could these enigmatic signals reveal about the universe? Stay tuned as we dive into this cosmic puzzle. Now, let's turn our attention to a discovery that has left astronomers both fascinated and puzzled: the mysterious radio circles, or ORC. First detected in 2020, these strange, circular emissions in the radio spectrum have sparked a wave of curiosity and debate. Unlike anything previously observed, these ORCs appear as faint, ring-like structures scattered across the cosmos, and their origins remain one of the most intriguing mysteries in modern astronomy. The discovery of ORCs was made possible by advanced radio telescopes, which revealed these ghostly rings spanning hundreds of thousands of light-years. What makes them so baffling is their unique structure, perfectly circular and seemingly isolated, with no visible source at their centers. Scientists have proposed several theories to explain their existence, but none have been confirmed. One leading idea suggests that ORCs could be the remnants of massive shock waves from galactic explosions, such as the collision of two supermassive black holes. These cataclysmic events could send ripples through space, creating the circular patterns we observe. Another theory points to the possibility of ORCs being the aftermath of a starburst, a period of intense star formation that generates powerful winds and radiation. These forces could carve out vast, circular regions in the surrounding gas and dust, leaving behind the radio emissions we detect. Yet, even this explanation doesn't fully account for the precise, ring-like shapes of ORCs. Some researchers have even speculated about more exotic origins, such as the interaction of dark matter or the effects of unknown cosmic phenomena. What makes ORCs particularly challenging to study is their rarity and the difficulty in observing them. Only a handful have been detected so far, and their faint signals make it hard to gather detailed data. Additionally, their large size means they often extend beyond the field of view of most telescopes, complicating efforts to analyze them fully. Despite these challenges, astronomers are determined to unravel the mystery, using cutting-edge technology and innovative observation techniques. The existence of ORCs reminds us that the universe is still full of surprises, even in an era of advanced technology and deep space exploration. They challenge our understanding of cosmic processes and push us to rethink what we know about the behavior of galaxies and the forces that shape them. As we continue to study these enigmatic circles, one thing is certain: they hold the potential to reveal new insights into the workings of the cosmos. With ORCs still shrouded in mystery, our journey through the unexplained takes us next to the Hubble tension, a discrepancy in the universe's expansion rate that has left scientists searching for answers. What could this cosmic puzzle tell us about the fate of the universe? Let's find out. Now, shifting our gaze to another cosmic puzzle, we arrive at the Hubble tension, a mystery that has astronomers scratching their heads over the universe's expansion rate. At the heart of this enigma lies a discrepancy between two methods of measuring how fast the universe is growing. On one hand, observations of nearby galaxies using the Hubble Space Telescope suggest one rate of expansion. On the other, measurements of the cosmic microwave background radiation, the faint afterglow of the Big Bang, point to a slightly slower rate. This inconsistency, though seemingly small, has profound implications for our understanding of the cosmos. The Hubble tension isn't just a minor disagreement, it's a challenge to the very foundation of modern cosmology. If the universe is expanding faster than our current models predict, it could mean that there's something missing in our understanding of physics. Perhaps dark energy, the mysterious force driving the universe's acceleration, behaves differently than we thought. Or maybe there's an entirely new component of the universe waiting to be discovered. Some scientists have even proposed that our understanding of gravity itself might need revision, hinting at the possibility of new physics beyond Einstein's theory of relativity. What makes this tension so intriguing is its potential to reshape our cosmic narrative. If the discrepancy holds, it could lead to groundbreaking discoveries about the nature of the universe. For instance, it might reveal that dark energy isn't constant but evolves over time, or that there are additional particles or forces at play that we haven't yet detected. These possibilities have sparked a wave of research, with astronomers using everything from supernova to gravitational waves to refine their measurements and uncover the truth. Yet, despite the excitement, the Hubble tension remains unresolved. Some researchers argue that the discrepancy could be due to systematic errors in our measurements, while others believe it's a sign of something far more profound. As the debate continues, one thing is clear: this cosmic puzzle is pushing the boundaries of our knowledge, forcing us to question what we think we know about the universe's past, present, and future. As we grapple with the implications of the Hubble tension, our exploration of the unexplained takes us next to the concept of galactic superwaves, a theory suggesting that periodic bursts of cosmic rays from the center of our galaxy could have dramatic effects on Earth. What could this mean for our planet, and how might it shape our understanding of the cosmos? Let's dive in. Now, let's turn our attention to a theory that sounds like it's straight out of a science fiction novel: galactic superwaves. This idea suggests that the center of our galaxy, the Milky Way, periodically sends out massive bursts of cosmic rays, and these waves could have significant effects on Earth. Imagine a ripple of energy so powerful that it travels across tens of thousands of light years, potentially influencing our planet's climate, atmosphere, and even the evolution of life itself. It's a bold claim, but one that has sparked both fascination and skepticism in the scientific community. The concept of galactic superwaves is rooted in the idea that the supermassive black hole at the heart of our galaxy, known as Sagittarius A star, might not be as quiet as it seems. While it's true that Sagittarius A star is currently dormant, some researchers believe it could have experienced violent outbursts in the past, sending shock waves of energy and particles across the galaxy. These waves, composed of high-energy cosmic rays, could travel vast distances, eventually reaching Earth. But what evidence supports this theory, and why does it remain so controversial? One piece of evidence comes from geological records. Scientists have found layers of sediment and ice cores that contain unusual spikes in radioactive isotopes such as beryllium-10 and carbon-14. These spikes suggest periods of increased cosmic ray activity in Earth's history, possibly linked to events originating from the galactic center. Additionally, some researchers point to the mysterious extinction events in Earth's past, like the disappearance of the dinosaurs, and speculate whether galactic superwaves could have played a role. However, linking these events to cosmic rays from the galactic center is far from straightforward, and many scientists remain unconvinced. Critics argue that the evidence is circumstantial at best. While it's true that cosmic rays can influence Earth's atmosphere and climate, attributing specific events to galactic superwaves requires a leap of faith. The distances involved are immense, and the mechanisms by which these waves could travel such vast stretches of space without dissipating are poorly understood. Moreover, the idea that our galaxy's center could produce such periodic bursts of energy is still largely theoretical, with no direct observations to confirm it. Despite the controversy, the theory of galactic superwaves continues to intrigue scientists and spark debate. If proven true, it could revolutionize our understanding of the Milky Way's history and its influence on Earth. It might also shed light on the broader question of how galaxies evolve and interact with their surroundings. For now, though, the idea remains on the fringes of mainstream science, a tantalizing possibility that challenges us to think beyond the boundaries of what we currently know. As we ponder the mysteries of galactic superwaves, our journey through the unexplained takes us next to the search for Planet 9. A hypothetical world lurking in the outer reaches of our solar system. Could this elusive planet hold the key to unlocking more cosmic secrets? Let's find out. Now, shifting our gaze closer to home, we delve into one of the most tantalizing mysteries within our own solar system, the search for Planet 9. This hypothetical world, believed to be lurking in the distant, icy reaches beyond Neptune, has captured the imagination of astronomers and space enthusiasts alike. Could there truly be an undiscovered planet 10 times the mass of Earth hiding in the shadows of our cosmic neighborhood? The evidence, while indirect, is compelling enough to keep the search alive. The story of Planet 9 begins with the peculiar behavior of objects in the Kuiper Belt, a region of icy bodies beyond Neptune. Astronomers have noticed that some of these objects, known as trans-Neptunian objects, follow orbits that seem oddly clustered and tilted. These orbits don't align with the gravitational influence of the known planets, suggesting that something massive, perhaps a ninth planet, is tugging on them from afar. This gravitational anomaly has led researchers to propose the existence of Planet 9, a world so distant that it could take between 10,000 and 20,000 years to complete a single orbit around the Sun. But finding this elusive planet is no easy task. Its extreme distance means it would reflect very little sunlight, making it incredibly faint and difficult to detect with even the most advanced telescopes. Adding to the challenge is the vast area of sky where Planet 9 could potentially be hiding. Astronomers have been scanning the heavens, searching for this needle in a cosmic haystack, but so far the planet remains undiscovered. Despite the lack of direct evidence, the gravitational clues continue to fuel the hunt. Critics of the Planet 9 hypothesis argue that the observed orbital anomalies could be explained by other factors, such as the combined gravitational influence of smaller Kuiper belt objects or even a passing star in the distant past. However, proponents counter that these explanations are less likely than the existence of a single, massive planet. The debate remains unresolved, keeping the mystery alive and the scientific community divided. If Planet 9 does exist, its discovery would be a monumental achievement, reshaping our understanding of the solar system's architecture and history. It could also provide insights into the formation of planets and the dynamics of distant orbits. For now, though, the search continues, a testament to humanity's enduring curiosity and determination to uncover the secrets of the cosmos. As we ponder the possibility of a hidden world in our solar system, our journey through the unexplained takes us next to the strange alignment of quasars across billions of light years. What could this cosmic pattern reveal about the universe's structure? Let's explore. Now, as we venture deeper into the cosmos, we encounter a phenomenon that challenges our understanding of the universe's structure: the mysterious alignment of quasars. These incredibly bright and distant objects, powered by supermassive black holes at the centers of galaxies, have been observed to align in ways that defy simple explanation. Stretching across billions of light years, this cosmic pattern raises profound questions about the forces shaping the universe on its largest scales. Quasars are among the most luminous objects in the universe, shining with the brilliance of trillions of stars. Despite their immense distances from Earth, their light allows astronomers to map their positions with remarkable precision. What's baffling is that, in certain regions of the sky, the rotation axes of these quasars appear to align with one another, as if they are connected by some unseen cosmic thread. This alignment spans distances so vast that it defies the principles of randomness we would expect in the universe. One possible explanation for this alignment lies in the influence of cosmic filaments, enormous, thread-like structures of dark matter and gas that form the backbone of the universe's large-scale structure. These filaments, which connect galaxies and galaxy clusters, could exert a subtle gravitational influence on quasars, causing their rotation axes to align over time. Another theory suggests that magnetic fields on a cosmic scale might play a role, though this remains speculative and difficult to prove. The implications of quasar alignment are profound. If confirmed, it could mean that the universe's structure is far more interconnected than we currently understand. It might also challenge the cosmological principle, which assumes that the universe is homogeneous and isotropic, essentially the same in all directions on large scales. The discovery of such alignments hints at a deeper level of cosmic organization, one that we are only beginning to glimpse. Some scientists have even proposed that these alignments could be evidence of a primordial influence from the early universe, such as quantum fluctuations during the Big Bang that set the stage for large-scale structures to form in specific patterns. Others caution that the observations could be the result of statistical anomalies or observational biases, emphasizing the need for further study. As we grapple with the mystery of quasar alignment, we are reminded of how much remains unknown about the universe's grand design. This discovery not only challenges our current models but also inspires us to look deeper, to question our assumptions, and to seek out the hidden connections that bind the cosmos together. With this cosmic puzzle still unresolved, our journey through the unexplained takes us next to a star that seems to defy time itself: the Methuselah star, a celestial object that appears older than the universe. What secrets does this ancient star hold? Let's find out. Now, shifting our gaze to a star that seems to defy the very fabric of time, we encounter the Methuselah star, a celestial enigma that challenges our understanding of the universe's age. Officially known as HD 140283, this ancient star has sparked intense debate among astronomers because its estimated age appears to exceed that of the universe itself. How can a star be older than the cosmos it resides in? This paradox has led scientists to re-examine both the star's properties and the foundations of cosmological models. The Methuselah star, located about 190 light-years from Earth, is a subgiant star that has been studied extensively for its composition and motion. By analyzing its brightness, temperature, and chemical makeup, astronomers initially estimated its age to be around 16 billion years, a figure that directly contradicts the widely accepted age of the universe, which is approximately 13.8 billion years. This discrepancy has left scientists scratching their heads, prompting a deeper dive into the methods used to calculate stellar ages. One key factor in this mystery lies in the star's low metal content. Stars formed early in the universe's history, like the Methuselah star, are typically metal-poor because heavier elements had not yet been produced in significant quantities. However, the exact relationship between a star's metal content and its age is complex, and small errors in measurement can lead to significant discrepancies. Recent studies have refined the star's age estimate, bringing it closer to 14.5 billion years, still older than the universe, but within a margin of error that allows for potential reconciliation. Another possibility is that our understanding of the universe's expansion rate, as measured by the Hubble constant, might need adjustment. If the universe is expanding faster than currently believed, it could mean that the cosmos is slightly older than we think, potentially closing the gap between the Methuselah star's age and the universe's age. Alternatively, the star's unusual properties might be the result of interactions with a companion star or other astrophysical processes that have altered its appearance over time. The Methuselah star serves as a humbling reminder that even our most well-established scientific models are subject to revision. It challenges us to refine our techniques, question our assumptions, and remain open to the possibility that the universe still holds secrets we have yet to uncover. As we continue to study this ancient star, we edge closer to resolving the paradox and deepening our understanding of the cosmos. With this celestial mystery still lingering, our exploration of the unexplained takes us next to the moon, where another enigma awaits: the mystery of its ancient magnetic field. What caused it to vanish, and what does it tell us about our closest cosmic neighbor? Let's find out. Turning our attention to Earth's closest companion, we uncover another cosmic puzzle: the moon's ancient magnetic field. Unlike Earth, which boasts a robust magnetic shield generated by its molten core, the moon today is magnetically quiet, but billions of years ago it was a different story. Evidence from lunar rocks brought back by the Apollo missions reveals that the moon once had a magnetic field, possibly even stronger than Earth's at the time. So, what happened to it? This mystery has puzzled scientists for decades, and the answers could reshape our understanding of not just the moon, but planetary evolution as a whole. The leading theory suggests that the moon's magnetic field was powered by a dynamo effect similar to Earth's. This process occurs when a molten, electrically conductive core generates a magnetic field through its motion. For the moon, this dynamo likely relied on heat from the decay of radioactive elements or the energy released during its formation. However, as the moon's core cooled over time, the dynamo weakened and the magnetic field faded away. But here's the twist: scientists estimate that the moon's magnetic field persisted for over 1 billion years, far longer than expected for such a small body. This raises questions about what kept the dynamo active for so long. One intriguing possibility is that the moon's orbit played a role. Early in its history, the moon was much closer to Earth, and the gravitational forces between the two bodies could have caused tidal heating within the moon's core. This additional heat might have sustained the dynamo, prolonging the magnetic field's existence. Another theory points to massive impacts on the lunar surface, which could have temporarily stirred the moon's core, reigniting the dynamo. Yet, these explanations are still speculative, and the exact mechanisms remain unclear. Adding to the mystery is the challenge of studying the moon's ancient magnetic field. Unlike Earth, the moon doesn't have plate tectonics to preserve its geological history. Instead, scientists rely on magnetic signatures locked in lunar rocks, which are difficult to interpret. Some rocks show strong magnetization, while others show none at all, making it hard to piece together a coherent timeline. Furthermore, the moon's small size means its core cooled much faster than Earth's, leaving fewer clues about its internal processes. The disappearance of the moon's magnetic field also has implications for its habitability. A magnetic field can protect a planet or moon from harmful solar radiation, and its absence on the moon raises questions about whether it could have ever supported life, even in its early history. As we continue to explore the moon through missions like Artemis, we may uncover more clues about its magnetic past and the forces that shaped it. The moon's magnetic field is a reminder that even familiar celestial bodies hold secrets waiting to be unraveled. As we delve deeper into this mystery, we gain not only a better understanding of the moon, but also insights into the broader processes that govern planetary evolution. And with that, we move forward to another cosmic enigma, the strange gamma-ray emissions emanating from the heart of our galaxy. What could be causing this mysterious glow? Let's find out. Now, let's journey to the heart of our galaxy, where a mysterious glow of gamma rays has left scientists scratching their heads. This phenomenon, known as the galactic center excess, is a strange and unexplained emission of high-energy light coming from the center of the Milky Way. Unlike the familiar glow of stars or the heat of cosmic dust, this gamma-ray signal doesn't fit neatly into any known category of astrophysical sources. So, what could be causing this enigmatic radiation? The answer might lie in some of the most elusive and fascinating aspects of the universe. One leading theory points to dark matter, the invisible substance that makes up about 85% of the matter in the universe. While dark matter doesn't emit light or interact with ordinary matter in ways we can easily detect, some scientists believe it could be responsible for the galactic center excess. The idea is that dark matter particles, when they collide, might annihilate each other, releasing energy in the form of gamma rays. If this is true, the excess could be our first direct glimpse into the nature of dark matter, offering clues about its properties and behavior. However, this theory is still speculative, and no one has yet found definitive proof that dark matter is the culprit. Another possibility is that the gamma rays are coming from a population of pulsars, rapidly spinning neutron stars that emit beams of radiation. Pulsars are known to produce gamma rays, and the dense environment at the galactic center could host thousands of these objects. If a large number of pulsars are clustered together, their combined emissions might explain the excess. But here's the catch: current observations haven't detected enough pulsars to fully account for the gamma-ray signal. This leaves scientists wondering whether there's an unseen population of pulsars or if another explanation is needed. Adding to the intrigue is the challenge of studying the galactic center itself. The region is crowded with stars, gas, and dust, making it difficult to observe clearly. The gamma-ray signal is also diffuse, meaning it's spread out over a large area rather than coming from a single, identifiable source. This makes it hard to pinpoint the exact cause of the excess, as multiple factors could be contributing to the signal. The galactic center excess is more than just a cosmic curiosity. It's a window into some of the most profound questions in astrophysics. Whether it's dark matter, pulsars, or something entirely unexpected, solving this mystery could revolutionize our understanding of the universe. As telescopes and instruments become more advanced, we may finally uncover the secrets behind this enigmatic glow. And with that, we turn our gaze to another cosmic puzzle. The largest known structure in the universe, the Hercules-Corona Borealis Great Wall. What makes this colossal formation so extraordinary? Let's explore. Now, shifting our focus to an even grander scale, we encounter the Hercules-Corona Borealis Great Wall, the largest known structure in the universe. Stretching across an astonishing 10 billion light-years, this colossal formation is a vast network of galaxies and galaxy clusters bound together by gravity. To put its size into perspective, it's so immense that it challenges one of the fundamental principles of cosmology, the cosmological principle. This principle states that, on a large enough scale, the universe should appear uniform and homogeneous with matter distributed evenly throughout. But the Hercules-Corona Borealis Great Wall defies this expectation, presenting a structure so enormous that it raises questions about our understanding of the universe's large-scale structure. The discovery of this cosmic giant came as a surprise to astronomers. While studying gamma-ray bursts, intense flashes of energy from distant galaxies, scientists noticed an unusual clustering of these events in a specific region of the sky. This clustering hinted at the presence of an enormous structure, later identified as the Hercules-Corona Borealis Great Wall. Its sheer size and density of galaxies make it a unique and puzzling feature in the cosmos. If the universe is supposed to be uniform on large scales, how did such a massive and irregular structure form? This question has sparked intense debate among cosmologists, with some suggesting that our current models of the universe's evolution might need revision. One of the key challenges posed by the Hercules-Corona Borealis Great Wall is its age. The structure is so vast that it would have required an extraordinary amount of time to form, potentially stretching the limits of what's possible within the known age of the universe. This has led some researchers to propose alternative theories, such as the influence of dark energy or the possibility of early universe conditions that allowed for such rapid growth. However, these ideas remain speculative, and the true nature of this cosmic behemoth continues to elude us. The implications of this discovery are profound. If structures like the Hercules-Corona Borealis Great Wall are more common than previously thought, it could mean that the universe is far more complex and varied than our current models suggest. It might also hint at new physics or forces at play, influencing the distribution of matter on the largest scales. As astronomers continue to map the universe with ever greater precision, the Hercules-Corona Borealis Great Wall serves as a reminder of how much we still have to learn about the cosmos. With this mind-boggling structure in mind, we now turn our attention to another vast and mysterious region of space, the Eridanus supervoid. What secrets does this enormous emptiness hold, and how does it connect to the cosmic puzzles we've already explored? Let's dive in. Now, let's journey into one of the most puzzling voids in the universe, the Eridanus supervoid. This enormous region of space, stretching over 1 billion light-years, is strikingly empty, containing far fewer galaxies and matter than expected. Its sheer size and emptiness make it one of the largest known structures in the cosmos, and its discovery has left astronomers scratching their heads. What could have caused such a vast expanse of nothingness, and how does it fit into our understanding of the universe? The Eridanus supervoid first came to light when scientists noticed an unusual cold spot in the cosmic microwave background radiation, or CMB. The CMB is the afterglow of the Big Bang, a snapshot of the universe's earliest moments, and it's remarkably uniform except for this one peculiar cold spot. Intrigued, researchers began to investigate, and their findings pointed to the Eridanus supervoid as a possible explanation. The idea is that the void's emptiness could cause light passing through it to lose energy, creating a colder region in the CMB. But while this theory seems plausible, it doesn't fully account for the size of the cold spot, leaving a gap in our understanding. One of the most fascinating aspects of the Eridanus supervoid is its potential connection to the CMB cold spot. If the void is indeed responsible for the cold spot, it would mean that this vast emptiness has a direct impact on the universe's earliest light. However, the scale of the void and the cold spot don't quite match up, leading some scientists to propose alternative explanations. Could the cold spot be evidence of a collision with a parallel universe, as some have suggested? Or is it a sign of new physics at work, challenging our current models of cosmology? These questions remain unanswered, adding to the mystery of this cosmic void. Another puzzling feature of the Eridanus supervoid is its formation. How does a region of space become so empty? One theory suggests that it's the result of gravitational interactions over billions of years, where matter was pulled away from the void, leaving behind a vast emptiness. Another possibility is that dark energy, the mysterious force driving the universe's expansion, played a role in creating the void. Yet, neither theory fully explains the void's size or its connection to the CMB cold spot, leaving scientists to continue their search for answers. The Eridanus supervoid challenges our understanding of the universe's structure and evolution. Its existence raises questions about the distribution of matter, the influence of dark energy, and even the possibility of parallel universes. As astronomers probe deeper into this cosmic mystery, the Eridanus supervoid serves as a reminder of how much we still have to learn about the vast and complex universe we inhabit. With this enigmatic void in mind, we now turn our attention to another cosmic oddity, the strange behavior of neutron stars. What causes these dense stellar remnants to glitch and burst in unpredictable ways? Let's explore this next mystery. Now, shifting our gaze to the densest objects in the universe, we encounter the strange and unpredictable behavior of neutron stars. These stellar remnants, born from the explosive deaths of massive stars, pack the mass of our Sun into a sphere no larger than a city. But what makes neutron stars truly fascinating and baffling are the sudden glitches and bursts they exhibit, defying our expectations of how such objects should behave. Neutron stars are like cosmic laboratories, offering a glimpse into the extremes of physics. Their intense gravitational fields and unimaginable densities create conditions that can't be replicated on Earth. Yet, despite their seemingly solid exteriors, neutron stars are far from static. They occasionally experience glitches where their rotation speeds up abruptly or emit sudden bursts of energy, leaving scientists puzzled. These events suggest that something extraordinary is happening beneath their surfaces, but what exactly? One leading theory points to the superfluid nature of a neutron star's interior. Imagine a fluid with zero friction, flowing effortlessly and without resistance. Scientists believe that the core of a neutron star may contain such a superfluid made up of neutrons. When this superfluid interacts with the star's solid crust, it could cause the star to suddenly spin faster, creating the glitches we observe. But while this explanation fits some observations, it doesn't account for all the strange behaviors neutron stars display, leaving room for further investigation. Another layer of mystery comes from the neutron star's magnetic fields, which are among the strongest in the universe. These fields can be trillions of times more powerful than Earth's, and they play a crucial role in the star's behavior. Some neutron stars, known as magnetars, have magnetic fields so intense that they can rip apart atoms and produce colossal bursts of X-rays and gamma rays. Yet, even with such extreme forces at play, the exact mechanisms behind these bursts remain unclear. Are they caused by starquakes where the star's crust cracks under immense pressure? Or do they result from magnetic reconnection, where the star's magnetic field lines snap and release energy? The answers are still out of reach. Adding to the complexity is the fact that neutron stars are not all the same. Some spin rapidly, emitting beams of radiation that we detect as pulsars, while others remain quiet until they suddenly flare up. This diversity makes it challenging to create a unified model that explains all neutron star behavior. Each glitch, each burst seems to tell a different story, forcing scientists to rethink their assumptions about these cosmic enigmas. The strange behavior of neutron stars challenges our understanding of matter, gravity, and magnetism under the most extreme conditions. As we continue to study these objects, they reveal just how much we still have to learn about the universe's most exotic phenomena. With each new observation, we edge closer to unraveling their secrets, but for now, neutron stars remain one of the cosmos' most captivating mysteries. As we ponder the peculiarities of neutron stars, let's turn our attention to another cosmic oddity, the phantom dark matter galaxy. How can a galaxy exist without the very substance that seems to hold the universe together? Let's explore this next enigma. Now, let's venture into a cosmic mystery that turns our understanding of galaxies on its head, the phantom dark matter galaxy. Dark matter, the invisible substance that makes up most of the universe's mass, is thought to be the glue that holds galaxies together. Without it, galaxies shouldn't exist as we know them. Yet, astronomers have discovered a galaxy that seems to defy this rule, appearing to have little to no dark matter at all. How is this possible, and what does it mean for our understanding of the cosmos? This peculiar galaxy, known as NGC 1052DF2, was first identified in 2018. Unlike most galaxies, which are dominated by dark matter, this one appears to be almost entirely made up of ordinary matter, stars, gas, and dust. At first, this discovery seemed impossible. Dark matter is believed to be essential for galaxy formation, providing the gravitational pull needed to gather gas and dust into the structures we observe. Without it, galaxies like NGC 1052DF2 shouldn't exist. So, what's going on here? One theory suggests that this galaxy might have lost its dark matter through a cosmic collision. Imagine two galaxies passing close to each other, their gravitational forces pulling and twisting their structures. In such an encounter, the dark matter from one galaxy could be stripped away, leaving behind a galaxy made mostly of ordinary matter. This idea aligns with observations of other galaxies that show signs of gravitational interactions, but it doesn't fully explain why NGC 1052DF2 is so unique. Another possibility is that this galaxy formed in an entirely different way. Perhaps it was born from gas ejected during a violent event, like the collision of two larger galaxies. This gas, free from the influence of dark matter, could have clumped together to form stars and eventually a galaxy. While this scenario is intriguing, it raises more questions than answers. How common is this process, and why don't we see more galaxies like this? The discovery of NGC 1052DF2 challenges one of the fundamental assumptions of modern astronomy, that dark matter is a universal component of galaxies. If this galaxy truly lacks dark matter, it could force scientists to rethink how galaxies form and evolve. It also raises the possibility that dark matter might not be as evenly distributed as we thought, or that there are different types of galaxies with unique formation histories. As astronomers continue to study this phantom galaxy, they are also searching for others like it. Finding more dark matter deficient galaxies could help us understand whether NGC 1052DF2 is a cosmic anomaly or part of a larger, undiscovered population. Either way, this discovery reminds us that the universe is full of surprises, and even our most well-established theories can be upended by a single observation. With this mystery still unfolding, let's turn our attention to another cosmic puzzle, the universe's missing lithium. Why is there less of this element in the cosmos than our models predict, and what could this tell us about the early universe? Let's explore this next enigma. Now, let's dive into one of the most puzzling mysteries in cosmology, the universe's missing lithium. When scientists look at the early universe, they expect to find a certain amount of lithium based on the predictions of the Big Bang theory. But here's the catch: the amount of lithium we actually observe is much lower than what our models suggest. This discrepancy has left astronomers scratching their heads for decades. Where did all the lithium go, and what does this mean for our understanding of the cosmos? To understand why this is such a big deal, let's take a step back. Lithium, along with hydrogen and helium, is one of the lightest elements in the universe. According to the Big Bang theory, these elements were created in the first few minutes after the universe began. The theory predicts very specific amounts of each element, and for the most part, these predictions match what we observe except for lithium. While hydrogen and helium are found in the expected quantities, lithium is about 3 times less abundant than it should be. This mismatch has become known as the lithium problem, and it's a problem that challenges our understanding of the early universe. So, what could be causing this discrepancy? One possibility is that our models of the Big Bang are incomplete. Maybe there's something we're missing about the conditions in the early universe that affects how lithium forms. Some scientists have proposed that new physics beyond our current understanding could be at play. For example, certain exotic particles or interactions might have altered the amount of lithium produced during the Big Bang. While this idea is intriguing, it's also highly speculative, and there's no direct evidence to support it yet. Another theory suggests that lithium might be destroyed over time. Stars, for instance, can burn lithium in their cores, effectively removing it from the cosmic inventory. However, this explanation doesn't fully account for the observed shortage, as the amount of lithium destroyed by stars doesn't seem to be enough to explain the discrepancy. Additionally, some lithium is created in stars through nuclear reactions, which complicates the picture even further. There's also the possibility that lithium is hiding in places we haven't looked yet. For example, it could be locked away in the atmospheres of certain types of stars or in regions of space that are difficult to observe. If this is the case, then our measurements of lithium might be incomplete, and the missing lithium could simply be in a form we haven't detected. The lithium problem isn't just a minor detail, it's a fundamental challenge to our understanding of the universe's origins. If we can't explain why lithium is missing, it could mean that our models of the Big Bang need to be revised. This would have far-reaching implications, not just for cosmology, but for our understanding of physics as a whole. It's a reminder that even the most well-established theories can have gaps, and that the universe still holds many secrets waiting to be uncovered. As we wrap up our exploration of the universe's missing lithium, we're reminded once again of how much we still have to learn about the cosmos. From phantom galaxies to mysterious elements, the universe continues to surprise us at every turn. And with that, we've reached the end of our journey through 30 space discoveries that defy explanation. But the story doesn't end here. There are countless more mysteries waiting to be explored. So, what do you think? Which of these discoveries fascinates you the most? Let us know in the comments below, and don't forget to subscribe for more cosmic adventures. Until next time, keep looking up, as we come to the end of our journey through 30 space discoveries that defy explanation. It's clear that the universe is far more mysterious and complex than we ever imagined. From the eerie silence of the wow signal to the baffling absence of lithium, each discovery challenges our understanding of the cosmos and reminds us how much we still have to learn. These mysteries aren't just scientific puzzles, they're invitations to explore, to question, and to dream. They show us that the universe is full of surprises waiting for us to uncover them. So, what does all of this mean for us? It means that the story of the universe is still being written, and we have a front-row seat to the greatest show in existence. Whether it's the strange behavior of neutron stars, the enigmatic dark energy accelerating the universe's expansion, or the possibility of a hidden ninth planet lurking in the outer solar system, these discoveries remind us that curiosity is our greatest tool. They inspire us to keep looking up, to keep asking questions, and to keep pushing the boundaries of what we know. As we wrap up, I want to thank you for joining me on this cosmic adventure. If these mysteries have sparked your curiosity, don't stop here. There's so much more to explore. Let me know in the comments which discovery fascinated you the most, or if there's a space mystery you'd like us to dive into next. And if you haven't already, hit that subscribe button and ring the notification bell so you never miss out on our next journey into the unknown. Until then, keep your eyes on the stars and your mind open to the endless possibilities of the cosmos. The universe is waiting for you.